that's got one less variable than we had before. So for instance, we might take, let's say that x1 is a binary variable. We might go ahead and set x1 equal to 1. If we did that, we would end up with a subproblem, or we could define a subproblem that's got one fewer decision variable, right? There's no decision associated with x1, right? Okay? There's no decision because we've chosen a value for it. So, so we're going to do a lot of that. We're going to do a lot of setting of the integer variables equal to a particular value and defining a subproblem. Okay? Now, if we define a subproblem and we're solving an overall maximization problem, and we go ahead and solve that subproblem and find an upper bound, maybe we could solve it exactly, or maybe we could find an upper bound on its value by solving a relaxation for it. And if that upper bound is less than the value of some known solution to the problem, then there's no point in worrying about the subproblem anymore. So what we'll be able to do, that's a bit abstract to think about without seeing the example that we're going to look at in just a second. But just as a preview, what we'll be able to do is chop out whole subproblems from consideration, because we know, based on an easy calculation, that it's not worth investing the hard calculation.
You mentioned maximization problems. Does that mean for this you don't have to turn into minimization problems?
That's right. I mean, this is a different thing than simplex. It will use the solution to linear programs as a subroutine. And maybe those linear programs will be maximization problems. And then if I said to you, now you have to figure out how to solve that linear program, then you'd be back to where we were before. You'd convert it into minimization problem and canonical objective constraint form and so on and do the simplex. On the other hand, we're going to sort of treat it, as we go through this, like somebody is giving us the answer to any linear program. So like, we'll just imagine that we have a very nice piece of software that'll solve any linear program. Okay. Okay. So, I want to try and hammer home this idea, though. Suppose that this is our picture. So the green, well, first of all, all of the dots, big dots, represent the feasible region for the integer program that we're trying to solve. Okay.